Hello. All right, let's get this started. So what is the molar mass of aluminum sulfate, or Al2SO4? The first thing we have to do is we have to find out the mass of each of those elements. So for aluminum, sorry, I'm writing with my fingers here. There are two aluminums right there, two aluminum atoms. So we're going to do 2 times, and the molar mass of aluminum is 26.98 grams per mole. Now we're going to find out what sulfur is. There are 3 atoms of sulfur. We've got 3 times the one that's the implied 1 right there. So we have 3 times, and the atomic mass of sulfur is 32.06. And now we're going to do oxygen. There are 12 oxygens. We've got our 3 right here, and we're going to multiply that by 4, which makes 12 oxygens. And the atomic mass of oxygen is 16. If we add all of those up together, multiply, and then add, we should get 342.14 grams per mole, or AMUs, atomic mass units. All right, now let's do number 2. How many moles are in 1.5 grams of aluminum sulfate? So we're looking for moles, and we have 1.5 grams. So all we're going to do, and I'm going to not write the formula aluminum sulfate out. So we got 1.5 grams, and we need to find moles. So I'm going to put moles on top, and I'm going to put grams on bottom, so my grams will cancel. Got a gram on top, gram on bottom, so they cancel. Grams per mole, we're going to use our units to help us decide what numbers to put here. So we have grams per mole, that's molar mass. We've already figured out what the molar mass is of aluminum sulfate, and it is 342.14 for every 1 mole. So we're going to do 1.5 divided by 342.14 grams, and we are going to get 4.4 times 10 to the minus 3. We have 2 significant digits right there, so our answer needs to have 2, and that is moles. I will also accept 0.0044. And the next question, how many grams of aluminum are in 1.5 grams of aluminum sulfate? So now we're dealing with 2 different compounds, so we're going to have to do our mole-mole ratio on here. So we're starting out with 1.5 grams of aluminum sulfate, Al2SO43. Sorry, my handwriting is not very good when I have to do it like this. Okay. So the first thing we're going to do, if we're at grams, we need to go to moles first. So I'm going to put moles. And I'm going to write aluminum sulfate up here because I don't want to run out of room. And we're going to put grams of aluminum sulfate down here, because once again, I don't want to run out of room. All right, this is grams per mole. That's molar mass. We've already figured out what our molar mass of aluminum sulfate is. It is 342.14, whoops, that's 0.14 grams per 1 mole. All right, but we're looking for grams of aluminum. So we're at moles of aluminum sulfate. Now, once we're at moles of a compound, we can go to moles of a different compound. So that's what I'm going to do. I'm going to put moles of aluminum up here. And then whatever units we have in the upper right, we put in the lower left. So moles of Al2SO43. And now for every 1 mole of aluminum sulfate we have 2 moles of aluminum. All right. I didn't leave enough room, so I'm going to continue this down here. We don't want moles of aluminum, we need grams of aluminum. So we need to write another chart, or another parentheses conversion. We're at moles of aluminum, so we're going to go to grams of aluminum. Whatever units we have on the upper left, we put to the lower right. So we have moles of aluminum on our upper left. So I'm going to put on my lower right, moles of aluminum. Grams per mole, that's the molar mass. The molar mass of aluminum is 26.98 grams for every 1 mole. So 1.5 divided by 342.14 times 2 times 26.98 and 2 significant digits, because 1.5 has 2 significant digits, would be 0.24 grams of aluminum. Okay, this is one way to do this. There is another way. It's a little bit shorter. This right here is what we did in step 2. So whatever you figured out in step 2, which is 0.0044 moles of Al2SO43, we can substitute that into there, and it will give you the same answer. All right, let's find out how many atoms of aluminum are 1.5 grams of aluminum sulfate. Again, we're starting with grams of one compound, and we need to go to atoms of another, a different compound or different element. So we're going to have to do a mole-mole ratio. Instead of starting with 1.5 grams, I'm going to go ahead and start with the moles, because I know I need to go to moles of aluminum sulfate, just like in problem 3. If you need to see where I'm starting, if you need to see why I'm starting with moles instead of grams, go back to problem 3 and you'll see. So we figured out that it's 0.0044 moles of Al2SO43. And we need to go to atoms of aluminum. So the first thing we're going to do is we're going to go to moles of aluminum. Because when we're at moles of one compound, we need to go to moles of a different compound if we're trying to get to that different compound. Whatever units are on the upper left, which is moles of aluminum sulfate, we're going to put on the lower right. So moles of Al2SO43 are going to go right here. Mole-mole ratio is usually a chemical equation, but we don't have a chemical equation here. We just have a compound, and we're looking for a specific element in that compound. So for every 1 mole of Al2SO4, we have 2 moles of aluminum. And now we need to do atoms. So for moles of aluminum, I can go to atoms of aluminum. And whatever unit I have in the upper left, I put in my lower right. So we've got moles of aluminum. I use my units to help me decide what numbers I'm going to put there. I have atoms and moles. That should tell you it's Avogadro's number. So I'm going to put 6.022 times 10 to the 23rd atoms for every 1 mole. So 0.0044 times 2 times 6.02 times 10 to the 23rd. We need 2 significant digits here. It's going to be 5.3. There's a dot there. That's a dot. Times 10 to the 21 atoms, or 10 to the 21st atoms. Okay, number 5. How many ions of sulfate are there? Technically, this should have brackets around it with this charge. So how many ions of sulfate are in 1.5 grams of aluminum sulfate? So again, we're going to go ahead and start out with our answer from number 2. 0.044 moles of aluminum sulfate and we're going to end up with ions of SO4. So the first thing we're going to do is we need to go, we're already at moles of one compound, so that's a good time to switch to moles of what it is we're looking for. So moles of SO4 ions. Whatever units we have in the upper left, we always put in the lower right for our stoichiometry. So that's Al2SO4 3. This is a mole-mole, so it's a mole-mole ratio. Since we don't have a chemical equation, we're going to look up into our compound. And for every 1 mole of Al2SO4, we have 3 moles of SO4. But we're not looking for moles of we're not looking for moles of SO4, we're looking for ions of SO4. So we need to find out how many ions we have. And from moles of SO4, we can go to ions of SO4. Whatever units we have on the upper left, we always put on the lower right. So we're going to do moles of SO4. Good boy. All right, ions per mole, those units tell us that we're going to use Avogadro's number. And we always put Avogadro's number by the atoms or ions. So 6.022 times 10 to the 23rd for every 1 mole. Multiply and divide this. Well, we don't have to divide by 1. So 0.0044 times 3 times 6.022 times 10 to the 23rd. And that equals 7.9 because we need to have 2 significant digits times 10 to the 21 ions of SO4 or SO4 sulfate ions. That's a 7. And the last one. Okay, there are several different ways you can do this. I showed you one way in class, or some people I showed one way. I'm going to show you a little bit different way on this one, whichever one makes most sense to you. Okay, so it says, what is the mass of 1 nitrogen molecule? So we're looking for grams. Whoops, we're looking for grams of N2. And we're starting out with 1 nitrogen molecule. So I'm going to do 1 molecule of nitrogen, and I need to end up with grams of nitrogen right here. That's what I need to end up with. So it's the same molecule, so we don't have to do a mole-mole ratio. You can do that, and I'll show that to you, but you don't have to. So we're at molecules of N2. If we need to find out what mass is, we need to convert to moles first. So molecules, we're going to go to moles of N2. Whatever units we have on the upper left, we always put on the lower right. So molecules of N2. Remember, moles and molecules are different. We have a molecule and a mole. That should tell you that we're going to use Avogadro's number. It goes next to the molecule, 6.022 times 10 to the 23rd. Molecules of N2 for every 1 mole of N2. But we're not looking for moles, we're looking for grams. And for moles of N2, we can go directly to grams of N2. Okay, so we have grams of N2. Whatever units we have in the upper left, we put in the lower right. Now we have a gram per mole. That should tell you molar mass. Now if you look here, it's grams of N2. So we have to take, nitrogen is 14.01. That's for 1 nitrogen, but we have 2 nitrogens, so we need to multiply that by 2. And that's going to go right there. So that's 28.02 grams of N2 for every 1 mole of N2. And that will give you 4.653 times 10 to the negative 23 grams. If we think about this, it should be a very small number, and this is a very small number because we're talking about the mass of just 1 nitrogen molecule. All right, I'm going to show you another way. If it makes more sense to you to do it this way, you're more than welcome to do it this way. Okay, so we're going to start out the same way. We have 1 molecule of N2. All right. And we're going to go to 1 mole of N2, just like the other step, and 6.022 times 10 to the 23rd molecules. I know this is hard to read, and I apologize for that. Okay, right here, you can add another step. So if you wanted to go to moles of nitrogen, so you'd have moles of nitrogen, not N2, not the diatomic, and moles, whatever units we have on the upper left, we always put on the lower right, so moles of N2. That's a mole-mole ratio, so we're going to look at the compound. For every 1 mole of N2, we have 2 moles of N. But we don't want moles of N, we want grams of N. So we're going to go directly to grams of N. Whatever units we have on the upper left, we put on the lower right. So moles of N, grams per mole is a molar mass. This is only 1 nitrogen, so we're going to do 14.01 grams for every 1 mole. All right, now let's cancel our units out to see what we're left with. So we got moles of nitrogen, molecules of nitrogen, so they cancel. Moles of N2 on top, moles of N2 on bottom, they cancel. Moles of N2 on top, moles of N on top, moles of N on bottom, so they cancel. We're left with grams of N. So 1 divided by 6.022 times 10 to the 23rd times 2 times 14.01 will still give you 4.653 times 10 to the minus 23 grams of nitrogen. Now if you notice, it is the same, and I will accept grams of nitrogen or grams of N2 as your units. It does not matter because there are 4.653 times 10 to the 23rd grams of N2 in 1 molecule of N2. And there's also 4.653 times 10 to the 23rd grams of N in 1 molecule of N2 because it's the same, the nitrogen. It's the same amount of nitrogen. I hope this helps.